Miles to everyone. Welcome to today's session, class 8th, topic square and square roots. In today's session, we will learn what are square numbers, some of its important properties and patterns, and we also learn about Pythagorean triplet. So let's start with square numbers.
So what is a square number? If a natural number m can be expressed as n raised to the power 2, or simply we can say n square, where n is also a natural number, then m is a square number. Or in simple word, we can understand that if any natural number that can be expressed as the power of 2 is called square number. For example, if we take 4, if we factorize 4, we can write 2 into 2. And in our previous class, chapter exponents and power, we have learned that if we are performing multiplication and bases are same, and then powers are added, so that means 2 into 2 can be written as 2 raised to the power 2, or simply we can say 2 square. In the same way, 9 can be written as 3 into 3, that means 3 square. In the same way, 16 can be written as 4 into 4, that means 4 square, and so on. So this type of number are called squares number or perfect squares. Here is a list of first 10 natural number and their squares. The square of 1 is 1, the square of 2 is 4, the square of 3 is 9, and square of 4 16. How do we get a square number? So what is the square number? Square is a when we multiply a number by itself, we get a square number. That means if we multiply 4 by 4, what we get? We get 16. In the same way, if we multiply 5 by 5, what we get? We get 25. So that means whenever we multiply any natural number by itself, we get a square number. Here are some properties of a square number. The first property is, here we can see in our square numbers that every square number ending with 0, 1, 4, 5, 6 or 9 only, and none of these square number is ending with 2, 3, 7 or 8. We can see here no square number end with 2, 3, 7 or 8. So here we can understand that every square number, that means any number which is square or perfect square, always end with 0, 1, 4, 5, 6 or 9. The second property is, if any number having 1 or 9 in its ones place will always have a square ending with 1. That means any number that has a unit or ones place as 1 or 9, the square number of that number will always end with 1. Okay. Third property is, any number which has 4 or 6 in its unit place, then square of that number will always end with 6, as we can see here in our examples. Okay. Fourth property, any number which has 0 in its unit place, its square will always have an even number of zeros at the end. Or we can simply understand that if any number has the number of zeros, the square of that number will have exactly double of that zero. That means if the number has only 1 0 in its ending, then it will have 2 0 in its square. And if a number has 2 0 in its ending, that means the square will have 4 zeros. If it has 3 0 in the ending, then the square of that number will have 6 zeros. I hope you got it. Okay. Now we learn some interesting pattern about square numbers. Adding triangular number. That means if we could arrange the dotted pattern of the number in a triangular form, then these numbers are called triangular number. That means if we take dots, only dots, and if we try to make any pattern by using these dots, and what is this pattern we are trying to make is triangle. If we try to make a triangle by using dots, so how many dots we need? So first we assume that one dot represent a triangle. Now if we have to make another triangle, so we need 3 dots. If we make head want to another consecutive triangle, so we need 5 dots, in the same way, and so on. So what our property says, if we add two consecutive triangular number, then we get a square. That means if we add 1 and 3, so it is 4. So we can arrange 4 by using dots as a square. In the same way, if we add 3 and 6, so we would have 9 dots. So that means we can arrange 9 dots as a square. So and so on. The second pattern is, if we take two consecutive number, like if we say n, then what is the another natural number? It's n plus 1. Then there will be 2n non-perfect square numbers between their square numbers. For example, let's take 5. So what is the consecutive of 5? It's 6. So if we find the square of 5 and 6, so what is the square of 5? It's 25, and the square of 6 is 36. So can you tell me, just by observing that, how many number between 25 and 36? So obviously they would be non-perfect square, because we are already taking two consecutive natural number and we are finding their square. So that means the square between 25 and 36 will be non-perfect square. So instead of counting from 25 to 36, we directly know that the square numbers, non-perfect square number between 25 and 36 would be 2n. That means what was our n? It was 5. So that means 2n means 2 into 5. So that means 10. So that means there are 10 non-perfect square number between 25 and 36. Let's move ahead. Adding odd numbers. Sum of first natural odd numbers. Remember, first odd numbers is n square. Or simply we can say that if we start from 1 and add consecutive natural odd numbers, then we get a square number. So it's a amazing pattern if you observe here. So here, if we have 1, we start from 1. So 1, how many number is 1? Obviously it is 1 digit, and this is only one number. So this is a square of 1. Okay, let's go further. If we add 1 plus 3, so we don't need to add them, we have to just see how many number are there. 1 plus 3, so that means we are adding two numbers. So that means this is a square of 2. So what is the square of 2? It's 4. So that means 1 plus 3 is 4. In the same way, if we keep adding natural odd numbers, if we take our fifth step, 1 plus 3 plus 7 plus 9. So instead of adding them, 1 plus 3 plus 5 plus 7 plus 9, we have to just count the that how many numbers are there. So that means 1, 3, 5, 7 and 9. So that means there are 5 numbers. So that means this is the square of 5. So we don't need to add them. We can just figure out that this is a square of 5. So what is the square of 5? It's 25. It is so easy. Isn't it amazing? Very amazing. Okay. Finding the square of a number. So basically, how to find a square of number? By multiplying a number by itself, we find a square of number. But instead of multiplying a number by itself, we have another method of finding a square. We can use this formula. For this, we have to divide a number by using plus or minus sign, and then we can use this formula. What is this formula? It is square of p plus q is equal to p square plus 2pq plus q square. Let's take an example and understand it better. Suppose we have to find the square of 53. So we know we generally find the square of 53 by multiplying 53 by 53, and we can get the square. But here we are using formula. So what is this formula? For first of all, we have to divide it into two parts. So we can write 53 as 50 plus 3. Then we can square it. So it becomes 50 square of 50 plus 3. So here 50 is working as a p and 3 is working as a q. So what is our formula? P square. So we will write 50 square plus 2pq. So 2pq we can write 2, 50 and 3. That means 2 into 50 into 3 plus q square. So instead of q square, we are writing here 3 square. Why? Because here 3 is working as a cube. Okay, now what is the square of 50? If we multiply 50 by 50, we get 2500 or 2500. And in the same way, plus 2 into 50 plus 3 is 300, plus what is the square of 3? It's 3 into 3, that is 9. So if we add all of these, we get 2809. So this is the same result as we get by multiplying 53 by 53. Okay, here is a another pattern for finding a square if a number ending with 5. So if any number ending with 5, we can find the square of that number by using this formula. So what we have to do, suppose the ones digit is 5, suppose, or what, it is ending digit as 5, we are using this formula for this. Okay, and tens digit is something, suppose tens digit is a. So what we have to do, we have to multiply the tens digit by adding 1 to itself. That means we have to add 1 to a, then whatever result we get, we have to multiply that result by a, then we will multiply our result by 100, then add 25. So we can see here in our examples, here 25. So what is the tens place? It is 2. So that means we will add 1 to 2. So that means it become 3. So we have to multiply 2 by 3, we will get 6. Then we have to multiply 6 by 100. So we get 600. Then we will add 600 to 25. So we will get 625. So that means square of 25 is 625. In the same way, square of 45. So how to find? We will add 1 to 4. So it will come 5. Then we will multiply 4 to 5. That means a. Then that means we are multiplying a by 2, a plus 1. So it is 4 into 5. Then we will multiply by 100. Then add 25, and so on. So for any number which has unit digit as 5, we can find the square of that number by using this pattern. Pythagorean triplet. If the sum of a square number is also a square number, that means if sum of any two square number is again a square number, then these three numbers form a Pythagorean triplet. For any natural number p which is greater than 1, we have 2p square plus p square minus 1 whole square is equal to p square plus 1 whole square. So this is our pattern. Okay, write a Pythagorean triplet having 4 as one of its member. So we know what are the member of the Pythagorean triplet. It's 2p, p square minus 1 and p square plus 1. So that means 4 will be one of them. So let 4 is the equal to 2p. So that means this is one of the member. So if we consider 4 as equal to 2p, so we can get the value of p from this. So that means the value of p will be 2. How? We will divide 4 by 2 and we get 2. Okay, so that means other two member, if we put the value of p in other two member, we can get other two members. That means p square plus 1, if we put the value of p, that means 2, so it will become 5. How? 2 square plus 1, so that means 4 plus 1, it's 5. In the same way, if we put the value of p in p square minus 1, we get 3. So that means these are the three member of the Pythagorean triplet. So we can check them by using our pattern. So what is the pattern? It's 2p square plus p square minus 1 whole square is equal to p square plus 1 whole square. So we put this value in this formula. It's 2p square plus p square minus 1 whole square plus is equal to p square plus 1 whole square. So that means 4 square plus 3 square is equal to 5 square. So that means 16 plus 9, 25. So these are our three Pythagorean triplet, 4, 5 and 3.
So I hope you have understood all the concept very well. See you in next video. Till then, stay safe, stay happy, be inquisitive. miles to go.